So here are 6 example problems where we're going to find domain and range. Okay, for number 1, the domain is all the x's. Okay, well, the lowest my x is -6, but it never actually gets there, right? It's an open one. So it's going to be -6. X has to be bigger than that, but not bigger than or equal to that. And then it goes, this arrow here says that it goes forever. So there is no smaller value for x, so I can just leave it like this. X is greater than -6. Okay? If I was doing that in interval notation, then once again I put -6 as my bottom value. And what's my biggest value? Well, my biggest value is infinity. Oops, let me do it better. My biggest value is infinity. And -6, it doesn't actually ever reach -6, so I'm going to leave that with a parenthesis. And it never actually reaches infinity. It keeps getting closer and closer and closer, so I'm going to put that as a parenthesis as well. Okay. What's the range? The range for this one, well, y equals 5. And that's it, because y is 5 along this entire line. This is a horizontal line with a slope of 0, so y equals 5. If I was going to do that in the intervals, it's just 5, and of course it includes 5, so I would put it in brackets. Okay, we'll do a different color. Now we can just keep the same color. Okay, number 2, what's my domain? My domain, well, let's see. It looks like x's go all the way. This arrow means they go all the way forever negative, and this arrow means they go forever and ever positive. So my domain is, I would just have to say that x equals, what would I do? I would say for the inequality, I would just say x is all real numbers. And to do that, we use this special symbol here, which means that's all real numbers. So that's all the way from negative infinity to positive infinity. If I was going to do that in interval, I would just say negative infinity, comma, positive infinity, and it never reaches either one, so I would use parentheses. All right, for my range, what are the y's? For my range, well, it looks like y gets all the way, the highest it gets is up here at that point 0. And the smallest it gets, it goes down and down and down. This arrow means it goes down and down and down forever and ever, as does this one. So the smallest my range is ever going to be is negative infinity. And the biggest it's ever going to get is 0. So I would say that just y is less than, and it looks like it includes that, less than or equal to 0. Putting that in interval notation, the smallest it ever is negative infinity. The biggest it ever is 0. And it includes 0 and doesn't include negative infinity. We never actually get there. So it would look like that. All right, number 3, this wiggly thing going all around, up, down, whatever. But we just want to find what are the biggest and smallest values for each one. So for my domain, for x, it looks like it goes from, this is -5 all the way to 7. So for my domain, I would say -5 and x and 7. And it looks like it includes -5, so x has to be bigger than or equal to -5. And this is a solid dot here to say that it includes 7. So x is less than or equal to 7. And doing that in my interval notation, that would just be -5, 7, and it includes -5, and it includes 7. For my range, it looks like the smallest y gets would be down here, that point right there, and that looks like -7. And the biggest y ever gets, looking up, is look for this point right here, and that looks like 6. And so y has to be less than 6 and greater than 7. And when I look, it includes this point -7. So I'm going to put a less than or equal to sign. And it includes the 6. So I would say it is y is less than or equal to 6. Because again, this is a solid dot. And this comes all the way down to here. So it would be -7 is less than or equal to y, which is less than or equal to 6. And so putting it in my other notation, my interval notation, that would just be -7, 6, and it includes -7 and it includes 6. All right, problem number 4. My domain is, what's the smallest x ever is -6. And what's the biggest x ever is? It looks like that's 6. And x is greater than -6, but it never actually gets to -6 because that's open. So I'm going to not say less. I'm not going to say -6 is less than or equal to. I'm just going to say less than. But then over here at 6, it actually does get all the way to 6 because that's a solid dot. So I would say x is less than or equal to 6. Or putting it in interval notation, -6, 6, it does not include -6, but it does include 6. My range, it looks like the smallest y ever is right down here at -1. The biggest y ever is all the way up here at, looks like 3. And so y is greater than -1 and less than 3. And then when I look at my dots at 3, it does not include 3. But down here, this is open. It does include -1. So I'd make this -1 is less than or equal to y. And then to use interval notation, I have -1 and 3, and it does not include 3, and it does include -1. All right, only 2 more. For our domain for number 5, it looks like x goes forever and ever to the left because of that arrow, and forever and ever to the right. So the domain is x is all real numbers. Or if I was going to do it in interval notation, it's -infinity to, -infinity to +infinity, and it does not include either of those. You can't actually get there. All right. The range looks like y is less than 0. The biggest it ever gets is right up here, and it includes 0. So y is less than or equal to 0. Or putting that in interval notation, the smallest it ever is -infinity. The biggest it ever is 0, and it includes 0, but does not include -infinity. We never get there. Finally, problem number 6. Our domain is, let's see, what's the smallest x is right over here at -7. The biggest x is up here at 4. And this is closed and this is closed, so it actually includes both. So it's x is greater than or equal to -7, but less than or equal to 4. Or putting that in interval notation, -7, 4, and it includes -7, it includes 4. And for our final problem, the range, it looks like the smallest y ever gets is all the way down here at -7. And the biggest y ever gets is up to here, which looks like 3. So y is greater than -7 and less than 3. And when I look, it includes -7 because that is a closed dot. So that would be included, so less than or equal to. And y goes all the way up to 3, which is up here, and it actually touches 3, so it would include 3. So I'm going to say y is less than or equal to 3. And then putting that in my interval notation, that would be -7, comma 3, and it includes 3, and it includes negative 7.